So there was a question regarding converting from radians to degrees. I'm going to show you two different approaches and why one approach only works in one situation and the other approach will work in every situation. So we know from the work that you've been doing that 180 degrees is the same thing as pi rads or radians. I very rarely use that symbol C that's indicated in the booklet, and the same thing with most people. Very few people use that little symbol C. So I point that out because let's say, for instance, I have 4 pi on 5, which is in radians, because you can see the pi expressed in your ratio. So when I see pi in that ratio, I can simply actually substitute in 180 degrees for pi, meaning it looks like this: 4 times 180 degrees, and divide that by 5. And then I haven't done this example before I started this, so I'm going to calculate it on my calculator. So 4 times 180, and then divide it by 5, and that's 144 degrees. But the challenge with this is that it only works when pi is actually in the original expression, where you can literally just substitute in. So that's one example, but it's limited. So another example is, let's say I have, 2.375 radians, and I want to convert that to degrees. Well, you also know from the booklet that you had this ratio of 180 degrees on pi radians. So you could think of this as simply a conversion problem that you might have seen in science, that if I use that ratio of 180 degrees on pi radians, have a look that technically that this 2.375 radians is technically on 1. And notice I explicitly included my units, radians and degrees, to show that, look, radians, as far as the units, cancel out. So therefore, all I need to do is, again, turn to my calculator, calculate 2.375 times 180 on pi, and I get 136, and I didn't indicate what to round to, so we'll round to, say, 2 decimals, so 0.08 degrees. So the second example obviously works in every case, and if I were to do that in example 1, you'd see that the pi's actually physically cancel out. So if you want an approach that will work in every single aspect of converting from radians to degrees, then I would use the approach that I showed you in the second example. Hopefully, if this doesn't make sense, you can shoot me a message and ask a question on Canvas.